For today, we do not have anything new. We're just going to use it in different ways. And so remember, to start off, if you want to take any old quadrilateral and figure out if it's a parallelogram, a rectangle, a rhombus, or square, you can actually do it with only two things, okay? And so you can do it by checking the congruency of the sides. Okay. What if just all the opposite sides are congruent? What do you automatically have?
Parallelogram.
You have a parallelogram. What if all four sides are congruent? Wrong. It's not a square. That doesn't include enough. It's a rhombus. Okay. Does having opposite sides congruent tell you if you have a rectangle?
No.
No. So the other thing you need to check actually is the diagonals. So check the congruency of the diagonals. Congruency has a U in it. That's a U. UNC of the diagonals. Because if the diagonals are congruent, what do you automatically have?
Parallelogram.
Well, no.
Rectangle.
If you have a parallelogram and the diagonals are congruent, it's automatically a rectangle. Oh. What if all four sides are congruent and the diagonals are congruent? That's going to be a square because it's both a rhombus and a rectangle. Notice none of this involved anything parallel, did it? No. And the reason we're not doing parallels, because, you can certainly use parallels, is because we're going to check just based on lengths. And so there are four possibilities here, okay? You could have opposite sides being congruent for step one, but the diagonals are not. And so you have your opposite sides are congruent there, and your opposite sides are congruent there, but the diagonals aren't congruent. In that case, all you would have is a parallelogram. Okay. Another choice is to have opposite sides being congruent, just like before. So it's still a parallelogram, but then I throw in the diagonals also being congruent, in which case you would have a rectangle. Because the diagonals congruent is a rectangle thing, and the opposite sides congruent is the parallelogram thing. Why do you have to have the opposite sides being congruent and the diagonals congruent to be a rectangle?
Because if just opposite sides are congruent,
it could be a trapezoid. If you didn't have the opposite sides, all the opposite sides congruent, but you did have the diagonals congruent, that could be an isosceles trapezoid, couldn't it? Yeah. So you have to have all the opposite sides congruent in order to be a rectangle. Okay? Our third possibility is that all four sides are congruent. What does that automatically give me? That gives you a rhombus. If the diagonals are not congruent, you don't have a square, do you?
No.
So having the four sides being congruent, the only thing you can get conclusively from that is being a rhombus. But if you get the all four sides being congruous and get the rhombus, and additionally your diagonals are congruent, what did the congruent diagonals tell you?
Squares.
No. It told you you had a rectangle. But what if you're a rectangle that's also a rhombus? Then you're the square. Okay? So you have to be able to keep those two different things straight. And I think on the answer key for the review that you'll be using when you check on Wednesday, see how I've broken up the different things to say, oh, this told me it was a rhombus. This told me it was a rectangle. This told me it was a parallelogram. Those kind of things are highlighted in there to kind of help you see my thought processes. So the whole reason we're reminding you of all this is because this is the kind of problem you're going to be doing on your homework. Could you graph it?
Yeah.
Are you required to?
No.
No. So all I need to do is check to see if my sides are congruent, and then check to see if my diagonals are congruent. Did it tell me how long they were, though? No. So you're going to have to figure it out. Now remember, this quadrilateral is going to go from A to B to C to D. See, that's the name of it. So I've got to start at A and go to B. That'll be one of my sides. Can I figure out its length?
Yeah.
Yeah, you learned that back in 7th grade. Then I'll need to go from B to C. Then I'll need to go from C to D. And then I'll need to go from D back to A. Those will be my 4 sides. So now I just got to remember, oh, garbage. How do I find the length of things on a graph? Well, that's how I get the distance between the x's. That's how I get how far apart sideways they are.
So y2 minus y1.
But if well, rise over run is slope. So if I had A was at, like, say, 9, negative 4, and B was at 8, negative 2, I would need to find out both the horizontal and the vertical so that I could use a right triangle to find that distance. Basically, you're using the Pythagorean theorem, but you learned it back in the day as your distance formula. And remember how it worked? You did your 2 x's, you found out how far apart they were. So you found out how far apart your x's were. Then you're going to square it for the Pythagorean theorem. And then we're going to find out how far apart your y's are and square those for the Pythagorean theorem. And do I want this hypotenuse squared or just the hypotenuse? Since you want just the hypotenuse, you have to square root everything. This part of the homework is not intended to be hard, but it's probably going to be pretty tedious. Tedious meaning, oh my gosh, kill me now, there's so much work to do. But it's okay, because, oh look, you have plenty of room and nothing but time. So from A to B, look what I'm going to have to do. I'm going to have to take the square root, and I'm going to have to do 2 things squared. What comes first, x or y? X. So I need to find the distance from the x in A to the x in B. So 9 minus 8. And then I need to do the y's. Negative 4 minus negative 2. Oh, what do you do when you get a double negative? Plus. Okay, and so then you go, okay, so what is 9 minus 8? 1, and that's going to get squared. And what's negative 4 plus 2?
Negative
2, and that's going to get squared. And then you go, okay, what's 1 squared?
1.
And what's negative 2
4.
squared?
4.
4. And when you add those together, you get the square root of?
5.
5. And let's just leave it in radical form for now because we can. Now, if I want a parallelogram, the side opposite from it will be congruent. Well, the side opposite of AB is going to be CD. So let's check CD. Let's do it. To get from C to D on your x's, you're going to go from 2 to 3, so 2 minus 3, and that'll get squared. And then for your y values, you're going from negative 5 to negative 7. So negative 5 minus negative 7, which becomes a plus plus. Well, what's negative 2 what's 2 minus 3?
Negative 1.
Squared. Positive 1. I'm skipping a step here. And then what's negative 5 plus 7? 2. Square it. 4. Which equals the square root of 5. Did my opposites match? But is that enough to say if it's a parallelogram? No. The one set of parallels right now, it could still be a trapezoid. Or sorry, this could be an isosceles trapezoid because it's got two congruents, not two parallels. Duh, Mrs. Cerna. So I've got to check more. So now you've got to check the other two sides. So go ahead on your paper with each other, figure out BC and DA.
This is so tedious.
It is tedious, but at least it's not hard. You have your best friend there to help you. Bless you. So I'm going to take my x's from BC and put them here. And now my y's from BC here, which is going to equal 6 squared plus 5 minus 2 is 3 squared, which will be 36 plus 9.
Equal 45.
Okay, square root of 45 for that guy. Now that could be simplified, but I don't need to simplify it. I just need to see if it equals what I get down here. So I'm going to see if it equals what I get for DA. So for DA, I need to go from 9 to 3. And then I need to go from -4 to -7. And that's going to give me 6 squared plus -3 squared, which will still give me 36 and 9, and still gives me the square root of 45. So now I have these two matching, and I have these two matching. Okay, so how many of you got this stuff?
Me?
You should have gotten two sides that were the square root of 5, which we found together, and the other two should have become the square root of 45. Now, can the square root of 45 be simplified?
Yes.
Yes, but is that going to be your answer in the end?
No.
No, so do you need to simplify it here? I mean, kind of yes and kind of no. You might want to because they might look different, and so you might want to simplify them and go, wait a minute, this is 9 times 5. That's a perfect square, so you get 3 root 5 and 3 root 5. Either way, are they congruent? So I have both sets of opposite sides congruent. So how much have I figured out so far?
It's a parallelogram or
I heard rectangle or parallelogram. Which is it for now?
either.
We don't know yet. I know for sure it's going to be a parallelogram because I've got opposite sides congruent. How do I test to see if it's a rectangle?
You go to the diagonal.
I check the diagonals. So for my diagonals, I'm going to need to go from A to C, and the other diagonal is going to go from B to D. But otherwise, it's the exact same thing. And I know it's not exciting. Not everything in the world is exciting. Train your brain to be able to work when stuff is not exciting. I promise you, it's not always exciting grading your stuff. But sometimes you just got to power through. And so from A to C, I need to go from 9 to 2, and I need to go from -4 to -5, which is going to give me 7 squared plus 1 squared, which is going to be square root of 50. And then for BD, I need to go from 8 to 3, and I need to go from -2 to -7, which is going to give me 8 minus 3 is 5 squared is 25, 7 minus 2 is 5 squared is 25, and that looks different right now, but when I end up working it out, you still get the square root of 50. And remember, that's simplified as 25 and 2